All right, in this second part, we're going to look at some code and talk about how they can be made into functions and the advantages of making the code into functions. In probably a third part, a shorter part, we'll talk about these last two items. So we're really talking about these two items here, making some functions and really thinking about parameters with some examples. So there's already some examples here that I've made and some code as well that we'll look at. So let's read the problem and then we'll talk about the example here, and then we'll write a function that will do the same thing as this code, but in a better format. For the following code, determine if the value of the number uses only one digit. For example, 33 uses just the digit 3. However, the number 7 also only uses one digit. Assume the value is less than 100 and greater than 0. So in this example, it doesn't really say what you're supposed to do if a number does use just one digit, but there are some print statements that at least convey that information. We also have a new built-in function here that we're going to use. It's called the input function. And when we use this function, we're actually going to get input from the user. We're also using another built-in function called int. The reason for this is that the input function actually returns whatever you enter as a string. So we have to convert the value to an integer if we know it's just going to be an integer. So we'll get a value, and here we use a trick of isolating the digits to figure out whether we have two digits or one digit. So this first section, this if statement is determining if the value has two digits. And the reason we know this is true is that if we divide something by 10 using integer division, then we're going to get a whole number. So if we take something like 34 divided by 10, well, we're going to get the number of times that 10 fits into 34, and we drop it in decimals. So we would get 3.4, but then we drop the 0.4, so we get 3. So if we get anything greater than 0, then we know we have a two-digit number. And we know our possible values can be either a two-digit number or a one-digit number. So if that's true, well, then we need to check if the first and second digit are the same. And this if statement here does just that. Checks if the first and second digit are the same. When we take modulus 10, well, modulus is going to get the remainder. So if our value is 34 and we say mod 10, the remainder is actually 4, the value 4. And 34 divided by 10 we know is 3. So you can use both of these to compare the first ones place digit and then the tens place digit. And if they're the same, then they use only one digit. If they're not, then they must use more than one digit. And the last part, well, if this is false, then we know it's just one digit, so therefore it has to only use one digit. It's only one possibility. So let's see, let's run this code. Okay, so it is waiting for us to enter a value. Let's try 34. So we'd expect to see that it uses two digits here. But the value uses more than one digit, so that works correctly. We should run it again with something that we would expect it does only use one digit, like 55. Okay, that works. And we should also test it with a single digit number. Alright, so it seems to work, right? Those three tests that we did are called unit tests. We'll talk more about these when we're talking about checker and project 1. But really we're trying to make sure with multiple examples that every possible case is covered, that it works for everything. So this code works, and it's following linearly in our script. But what would happen if later in a code we needed to do this same problem? Well, we just have to copy paste this code. We have to take all this code here, copy it, paste it here. And then if we ever needed to change part of this code, let's say we wanted to include numbers less than 1,000, well, now we have to change this code and this code. We have to find all the places where the code is written twice and change both. And that's not a great idea. We're going to start missing things. We might forget we even had the code in 2 different places or 3 different places or many different places. So that's a big issue. The other issue is, I printed something to the screen, but if I wanted to use that information later to know whether this value has multiple digits or not, I'm not going to know, because the thing that is printed to the screen is only visual, right? We print this string to the screen and that's it, right? We don't have anything stored in variables. So these print statements are really an issue because we can't use that data after we print something. And I would say another issue is this input function. The input function works, but do we really want to have the user input a value for everything? Maybe not. And if we did run this program and enter something that was not a number, like chicken, well, we get an error. So that's not great either. So let's try and write this as a function. Use what we know. We're going to write def because that's how we start our function. Then we need a name for what we're really doing here. I would say that this function is, I would say it's telling whether a number has more than one digit or not. So maybe I'll call it something like has multiple digits. This is a common way of writing function names. Our verb here is has, actually. It's kind of like a weak verb, but it also indicates that our result here is going to be true or false. Right? There's only one possibility here. Either it's true that we are only using one digit in our number, or false. And now we can make a parameter for the value that we're looking at. So before we were using this input function to get a value. Now we're just going to stick a, it doesn't like my, that we're using value twice here. We'll call it number. Now this is acting like a local variable, like we said before. So whatever's passed in here, we create a new variable called number, so that we can work with that number. Now I'm going to copy some of this, and we're going to replace some things. So a lot of this is fine. The logic here is fine, these first few lines, and the comments are fine. But for these print statements, not really what we want. We would like to use return values so that we can use that data after we use this function. So when we have two values that are the same, we would say that, does this have multiple digits? No. So we're actually returning false here and returning true here. And this would also be return false. Okay, and that's all our function is. Right, very similar, but it's going to have a lot of advantages. For one, when we call this function, we can actually get the result and store it in a variable. I'm going to call the result uses multiple digits, and we're calling the function has multiple digits, and then we can test a number, 72. So that true or false value will be stored in here, and then we can use that later on. Like if we wanted to use this in an if statement, we could do that and then use that data, whereas before we could not use that data. If it does use multiple digits, we can say uses multiple digits, just so we can see this working. this is our first. This is not our function here that we made. It's the code above. Since we still have that input function in our script. Okay. Something I would recommend is something we saw in the example in the last video. Is we have all these little comments here that uses these triple quotes. Oops. If we add those to this function, it's going to automatically generate these little tags here, which are going to help define what our parameter is supposed to represent and what exactly we're returning in the function. And we can also leave a note for what this function does. So I would say something like this function returns true if the number uses multiple digits, and false if the number uses only one digit. Maybe we put a note here because we have a restriction to our domain. We are only allowed to use values less than 100 and greater than 0. So I'll say the number must be greater than 0 and less than 100. For the parameter here, I would say something like a value that is greater, maybe I should say a whole number that is greater than, you should say, should I mention that it has to be a whole number? Probably. If the whole number uses multiple digits, and false if the whole number uses only one digit. Okay. A whole number that is greater than 0 and less than 100. And what am I returning? I'm returning true if the number has multiple digits, or uses multiple digits, and false otherwise. All right, a lot of writing, and I'm not saying you have to do all this detail, but having at least a little note is going to be helpful, and it's something I might require in the future, and we might test on this as well. All right, let's go to this section. What advantages are there? Let's just make some notes of what we talked about. Oops. Right, advantage number 1, we can reuse the function without copy pasting code. Number 2, we can actually get a value to return. And we could have stored a value in a variable here, but it's a little bit more messy. Another advantage is this function can exist without us using it. So we can write a function and not use it, whereas the code in the script directly is always run. So anytime we press this play button, anything that is just sitting in the, with no indentation, that's the scope is the entire script, right? This is always going to be run here, and this is always going to be run. And so, a lot of times we don't really want that. Are there other advantages? Yes. We've mentioned this before, but functions help organize and label our code, right? Helps us understand things better. What else? I would say that's the main things. We pretty much covered it. Oh, you know what? I just saw here that number is being used, but not the right variable name here. Should have been saying number. It's funny that that actually worked. Okay, well, so let's move on. Let's look at this next function, and this is the last one for this video. Now we could look at some code that doesn't use a function for this, but we're just going to go straight to writing a function. In the next part, we'll write more functions, focusing on the last two bullet points here, using multiple return types and default parameter values. Okay, so write code that finds whether two numbers are related through a mediator number. Two numbers are related if the first number can be used with any operator and the mediator number in order to equal the second number. For example, the two numbers 5 and 23 and the mediator 9, for these numbers are related using the mediator 9, since 23 mod 9 is 5. Right, 9 times 2 is 18, leaves a remainder 5. Another example, if we have the numbers 24 and 27 and the mediator 3, these numbers are not related using the mediator 3, since any of these operators can be used to change 7 to become 24 or 24 to become 7. All right, let's write this function. I'm going to say the function's name is find related. We've got two numbers. We'll call them A, B, and mediator. And we want to see whether they're related or not. So we're going to need some if statements. If A plus, let's see, mediator is equal to B, or B plus mediator is equal to A. So we'll just do all of our operators in a row. We'll say return true. All right, so that covers every situation for the plus operator. And it looks like everything after this is going to be pretty similar. So let's do some copy pasting. Copy pasting is always good. So it's like minus, times, divide, modulus. What am I forgetting? Let's start with that. Minus, times, division, modulus, and exponent. Could we use just an else here? I think so, if it's our last option. Oh wait, no we can't. Scratch that. Yeah, we cannot do that because our else should actually be return false. So if none of those are true, if we can't equal a number by any of those methods, well, it must be false. Now, here's a good question. Does this actually cover all of our cases? What do you think? The answer is no, but why? The reason is that some of these operators are not commutative, right? If you've heard that term before, there's only two commutative operators, addition and multiplication, because you get the same thing whether they're in one order or another. But the same is not true for subtracting, division, modulus, or exponents. So we need to add some extra lines here. All right, first thing we can do, we need to take mediator minus A and B minus mediator. So we'll kind of do some copy pasting. B minus mediator, and that covers all our additional cases. You're going to see I did something new here. I put a little /. That's that key above the enter key in order to move it to the next line. this tells Python that this line here still belongs to this one. Otherwise, it's not going to know. And the little indent here is just a visual indicator to show that this isn't part of the scope. Right? Just this is part of the scope. We could, delete this and write it like this, but then things start not being able to fit on your screen. So this is pretty helpful to do. Okay, so we need to do the same thing for division. I'm just going to copy paste this and then adjust some things. Divided by A. And it should be mediator divided by B. Let's see, it doesn't like this line because I forgot my OR. Okay, and do this. You do the same thing for these lines. I'll set this up now. So we're going to copy this and say mod A and mediator mod B. Okay, looks good. And one more. And mediator exponent B. All right. A lot of stuff there. Now, is this good? Well, maybe. One thing this didn't say is whether we can use whole numbers or not. I think I kind of want to restrict this to just use whole numbers. So that fixes that, so we don't have to worry about the single division, the normal division. And there's one more issue. What happens if A or B is 0? Well, that's fine and all, except for these guys, right? Because both of these would trigger the dividing by 0. So what we should do is make some stipulation here, because I think we want this to return false if one of these is going to divide by 0. So what can we do here? So I would say in this clause here, if mediator is 0, we want this to kind of short circuit. So what can we do? If mediator is equal to 0, it's not equal to 0, and this is true. Let's see, would that work? So both of these have to be true in order for this to be true in this case. I think it's what we want. If we added a lot of parentheses here, which I had to make work, which I had to use to make this work. So take a second and prove to yourself that this is what is needed in order for this to be true. And if this is false, then this will short circuit, since this will be false. Then it will also allow us to check if we can do these lines, because it's okay if mediator is 0 if we're dividing it by A, right? So we're going to do the same thing for these two lines here. We will put these in parentheses. I guess we need 2 here, and here we're checking if A is not equal to 0, like that. And we'll do something very similar here for this line, and same thing with A. Ooh, we have B here too. Oh, okay, we'll have to fix that. So we don't want just if A is not equal to 0. Maybe we should separate this into 2 clauses. I think that's the answer. What we should do. So we should say if A is not equal to 0 and we do this, or we do something very similar here with B. So if B is not equal to 0 and that. Yeah, I like that better. All right, and we'll do the same thing here. Whoops. So what is this? Or b is not equal to 0. All right. And let's see, using exponent with 0 is fine, so we're okay there. So if you look at this expression, this is why truth tables become really important in our practice of using truth tables, because you kind of have to be pretty good at evaluating these clauses with those parentheses, which is what we did in that homework, in order for this to not freak you out too bad, right? It is confusing to look at, but once you think about it, you should be able to figure these kind of clauses out. All right, and that's that function. Now we could make some notes here. We could say determines whether A and B are related through an operator using a mediator value. Assume all values are whole numbers. This is just the first value, this is the second value, so the context of the name isn't very important. This is the value that is being used with a number and an operator. And the return value, so true if the values are related, false otherwise. All right, we'll talk more about how to know whether this works or not in the next video. We'll split it. Let's push to the next one.